Okay, today's lesson will be solving equations with variables on both sides of the equation. And we'll use some of the vocabulary distributive property, combining like terms, and collecting like terms. One of the abbreviations I use a lot is CLT, and really that's going to apply to both combining and collecting like terms. They're very, very similar, and we'll talk a lot about that in the upcoming. Okay, today's lesson is essentially picking sides. And what I mean is, on an equation, you just need to pick one side or the other. So one side you are going to collect all your variable terms, and the other side you'll basically collect your constants. And once you get them all on one side or the other, you're really ready to solve the equation and get the variable alone. So let's do some example problems. Okay. Our first problem, 7x equals 4x plus 15. Notice we have variables on both sides of the equation, so I'm just going to collect all my variables on one side, and I can collect it on either side. I'm going to pick the left side for my variable terms and the right side for my constant terms. You can pick that any way you want. I choose to do it for a simple reason. I like to look at the coefficient, and whatever side the coefficient is larger, and this side 7 is obviously larger than 4, that's where I want to collect my variable terms. That way I get to avoid negative coefficients. So to get the 4x off of this side, I subtract 4x, but if I do it from this side, I of course do it from this side. These are like terms, and so we can subtract them. 7x minus 4x is of course 3x. This 15 just goes for a ride, and at this point we could just solve for x. Divide both sides by 3 to make the coefficient 1 here, and that is isolating the variable, and x equals 5. Okay, I'd like you to try this equation, so please pause it and try. Okay, again we're going to collect all our variables on one side, and I noticed that the coefficient here 5 is larger than 3, so I'm going to put my variables on this side, my constants on the other side. So I want to get this constant, or this variable term off the constant side, and to do that I'm going to subtract 3x. Of course, when I do that, it goes away, or basically it sums to 0. But of course, if I subtract 3x from one side, I have to do it to the other. 5x minus 3x is 2x. These guys just come along for the ride. And essentially we're at a two-step equation now. I add 2 to this side and 2 to this side. We'll get rid of this 2, and notice that's a constant on the variable side. So I'm staying consistent. Variable, I have one variable term. Constant, I have one constant term. I'm ready for my final step, and that is to get the coefficient as 1. So I divide both sides by 2, and I get x equals 3. Okay, give this one a try. Alright, again I noticed that the coefficient 9 is larger than the coefficient 5, so I'm going to collect all my variable terms on the left side. So I'm going to subtract 5n from both sides, because this is a variable term that's on the constant side, and I want to eliminate him. When I subtract 5n, he goes to 0. But if I do it to one side, I do it to the other, leaving 4n minus 6 equals 18. At this point, it's just a simple two-step equation. I add 6 to both sides. Now I have just a variable term on one side and a constant on the other. And my last step, of course, is divide by 4, which gives me n equals 6. Okay, give this one a try. Okay, I hope you noticed that on both sides of the equation now I have 3 terms. Okay, so it's best to simplify each expression. Remember, this is an expression, this is an expression. Let's simplify before we start tackling solving it. So I notice on the left side I have these like terms because of the same variable with the same power. And 6y minus 3y gives me a 3y. I still have this constant on this side. Here I have 2 constants on this side, so I can go ahead and add those. Y, a negative 5 and a positive 17 is a positive 12. So now that I've cleaned that up and simplified each side, I can now go through the process of collecting my like terms. And what I'm going to do is I'm going to collect my variables on the left side because, again, I have a coefficient of 3. Here I have a coefficient of 1. So I want to get rid of that 1y by subtracting y. But of course, if I do it on this side, I do it on this side, getting me to here. Basic two-step equation at this point. Subtract 4 from both sides, leaving my variable term on this side, and 12 minus 4, of course, is 8. Divide both sides by 2. All right, take a second to do this problem. Okay, so what I have here, notice on the left side, I can simplify this first, and I will. I'm going to collect like term, or rather combine like terms on this side, 7x minus a 3x. Once I get to this point, it's all set up to do some collecting, and now I notice that my variable is larger on the right side. So I'm going to go ahead and collect my variable terms on the right side. And that's really where I like to focus, is my variable terms, because the x is what I'm wanting to get alone, and so it's important to me to keep my coefficients positive. It just makes it easier at the end. So we're going to subtract 1x from both the left side and the right side. And now I'm all set up. It's a typical two-step equation. I want to subtract 13 from both sides and divide by a positive 3 to get x alone. Okay, our last problem, we have a
May I have your attention, please? Oh. All cheerleaders, please report to the gym. All cheerleaders, please report to the gym.
Okay, that was weird. Okay, now we're going to go ahead and we can tackle this problem in one of two ways. I can either simplify first this, combine like terms, or I can distribute on this side. Either way, whatever I do, remember, I'm just simplifying on one side of the equation or the other. Okay. Oops, forgot to do that. So I distribute, get to here. I'm going to combine like terms over here. Now I'm to where I want to make some decisions. And now I look at my coefficients and I notice which one is larger, -3 or -6. Well, actually, -3 is larger. So I want to put my variable terms on the left side and my constants on the right. So this is a variable term. He's okay here. I have to get rid of this guy. So I'm going to add 6k to this side, but I'm going to add it to this side as well. And 3k equals 3. Divide both sides by 3. K equals 1. Okay, that's our 6 problems, and I look forward to seeing you in class with any questions that you may have.